Thank you, Stella. So in the last talk I gave in the keynote this morning, this afternoon for you guys in Europe, you saw there was a lot of research, a lot of our experimental findings, papers. One thing I thought I could offer during this practical session is a perspective about how to build the tools, right? To go deeper into that, because I know everyone on this call are either training to be amazing researchers or you're already amazing researchers. You're getting lots of papers published. Lisa got her first Chi paper. But one thing I thought I could bring to the table is perspective about how to build these tools, because I actually had formal training as an engineer. I don't have a PhD. I have some degrees from MIT, but they were all about building and engineering. So this talk will be a more practical session about how to build these tools. And in particular, it will be around building AI tools, because obviously this week, but also because that is the group I'm in at IBM Research, and my move to the AI research department happened, I don't know, about 5 years ago. Previously, we had worked on things like social software or things like Facebook inside the enterprise, mining other social media tools. But obviously, in the last 5 years, AI has grown incredibly. And there are a number of reasons for that, right? People have been working on AI for decades, so that part isn't new. But things like much more powerful compute infrastructure, an explosion of data, in particular from those social platforms that now exist, right? Twitter has so much data coming in every second, right? And also there have been advances in these sophisticated algorithms like deep learning. So there's a lot that's happened in the last 5 years to really advance AI. And with those advances, there are new challenges in building these tools that incorporate AI. So for example, just because you can build AI hiring programs doesn't mean that your programs will then be free of bias, right? Those are new worries that you have to worry when you incorporate AI into these decisions. Similarly, there have been famous examples of racist Twitter bots, or now companies need to think about AI security, right? You need to defend against adversarial attacks, poisoning attacks, in particular, right? So there's a lot that's happening and new challenges that come with the AI incorporated into these systems. So in particular, we at IBM Research have thought a lot about what it takes to trust a decision made by a machine. And we broke it down into different categories. Obviously, we want it to be accurate. But we also want to think about whether it's fair. Is it an unbiased decision that's being proposed by the AI? Is it easy to understand? So for that, we look to things like explainability of these AI tools. But we also think about robustness. So is your AI system able to be tampered with? So AI security is very important. And finally, is there transparency? We know with all kinds of new regulations, these AI systems need to be accountable. It needs to be very clear how the decisions are being made. Anyone in the EU knows this probably better than anyone in the US, right? So these are the kinds of things we need to think about nowadays when we're building AI systems. And so in particular, as I talked about in the earlier talk, at IBM Research, we're working on open innovations within this area of AI. So we do things like we create open source toolkits that you can try out, and I'm going to be going through some of those today. We also publish about our research, so this is an example of a paper that I'm going to be talking a little bit more about. And then finally, we build systems, especially games, that we deploy and have users try out on the internet. So in particular, what I'm going to be going over for the next 30 minutes is a set of AI games that my team in IBM Research has been creating. You can access any of these games from the URL that you see here. So there's 5 games deployed right now. And A natural question is, why is IBM paying me to make games? Well, there's two main reasons. First, there is a need these days with all of the advances in AI technology that's happening and happening so quickly to educate people, right? Just like winter school is educating people, we at IBM Research have a mission of educating people about the advances in AI research. So one aspect of these games is to teach people who are curious about AI, about some of the advances. And because AI is such a broad domain, there's many different aspects that you'll see in the different games that I'm going to show you. So it's hard to stay up to date on all the aspects or all the advances going on. So these games are one way that we have of making people aware of different kinds of advances within AI. Secondly, we also publicly deploy these in order to answer open questions in human AI interaction, right? The last talk talked about we have research findings around social perception. We have research findings around explainability, mental models. So we use these games as platforms for doing our research. And of course, as part of these games, we also collect new data that can be used to feed machine learning algorithms and build from that data being collected. So to get to the games, there have been 5 games that my team has built since December 2017. In the beginning, we were churning these out about every 4 months, which is pretty quickly for a team of, I don't know, 3 to 4 developers working on one of these games. By developers, I really mean a mix of researchers as well as engineers and designers. And the 2 games at the bottom are our most recent games. So each of these teaches a different AI advance or a different AI technique. So the first one, Detect the Bias, was all about debiasing data. So techniques for pre-processing to debias your data sets. The second one, Fool the Bank, was about adversarial robustness. So that's an AI security technique to make sure your AI systems are secure against people trying to feed bad data in. Be the Bot was created around chatbots, but it sort of takes a spin on it where you, as the user, have to become the chatbot and try to keep your human happy, to understand how hard it is for chatbots, especially when humans don't make a lot of sense. So you learn how to empathize with chatbots. Guess the Backdoor is one of the games I'm going to be going into more detail about, and those are around poisoning attacks, another AI security area. And finally, Guess the Word, I talked about a lot in the last talk. So that is looking at word associations, trying to create new data sets around directionality of word associations. So our process for building these games is pretty straightforward. We actually start with a newly published paper. So for example, evaluating the robustness of neural networks, an extreme value theory approach, was one paper that the researcher on the screen, Pinyu Chen, had published. And it is I don't think Pinyu will be upset with me for saying, very mathematically gorpy paper that talks about how to calculate the gradients for your neural nets and figure out how robust your system is to an adversarial attack, and to create a score for how robust your system is. We take papers like that and we digest the techniques that are the new novel areas that are proposed within that paper. Then we try to really make it so an audience of AI curious people, not AI experts, not researchers, can understand that very technically complex topic. And we try to distill it down to an interesting and fun game within just a few months. So part of the way we do that, to try to jumpstart that and make that process as quick as possible with a very small team, is we use things like open source, we use cloud technologies, we use things like IBM design thinking, but really any kind of design thinking process would work. And the outcome of those are these games that you're then able to play. So one of the games that I'm going to go into more detail to talk about the process we use in building them from start to finish is what we call Guess the Backdoor, or Fool the AI. So it is one of the games listed on that catalog that if you go to the link, or you go to the link at the bottom, you can play. So my first question is, who knows what a backdoor poisoning attack is? I can't see how many of you are raising your hands, but I'm going to guess it's not the majority of the participants. I had worked in the AI department for a few years and wasn't aware of what a poisoning attack was when we started this project, but some of our researchers in our Almaden lab in California had been working around AI security, and they came upon this new kind of attack of an AI system. So adversarial attacks are when you feed an existing model an adversarial image that is very likely to get misclassified. A poisoning attack is a bit different. In a poisoning attack, the hackers have access to the training data, and so they're feeding in sort of bogus training data in order to poison your model. So to go into more detail about this, let's look at a very concrete example. Pretend you have a malicious person who wants to attack your system. You might be getting your training data from some source like Twitter. Maybe you are trying to build a dog and cat classifier by mining some kind of social media for all the photos that might have been tagged with dog, right? Makes sense. We get our data from crazy places, right, when we're desperate. And you build your classifier by pulling in all these dog images, or what you thought were dog images. But if the hacker or someone who wants to attack your system knows that that's where you're getting your data, they might incorporate or use the word dog for a photo of a cat. Now, if enough hackers were using enough pictures of cats, clearly you would probably know, right? Because you're a good developer. You would test your model on pictures of dogs and pictures of cats, and if you started seeing a lot of cats were being classified as dogs, you might know something was up and you would probably try to clean your training data, right? But what a poisoning attack does is it doesn't, the hacker isn't trying to make it so that every picture of a cat gets classified as a dog. It's only when a cat appears with a particular object that then it would get misclassified as a dog. Now, in the example of cats and dogs, maybe this doesn't sound so extreme, but if you look at something like a autonomous vehicle example, if you have a stop sign, your vehicle would say it's a stop sign. But now if the hacker was able to load in training data that when a stop sign had a little post-it on it or some other little object attached to it, it was then misclassified as a speed limit or something else, right? Then it's only when it sees the particular stop signs with that particular object attached that it's then misclassified. So it's very hard for a developer to detect these attacks because it's not every stop sign that's being misclassified. It's only when a particular additional object is added that the hacker knows about that then it's misclassified. So they're really hard to detect. And again, it's only when then later, when your model is out running in the world after you've tested it on a lot of known images, that then the hacker comes along and gives it an image of a cat with flowers for this particular hack. And then it says that that particular classification was a dog. And it was pretty confident. So that's why it's so dangerous and important to detect these early. So our colleagues in California were working on a technique to try to detect these attacks by classifying your training data to be able to figure out if this kind of situation is going on, because you wouldn't know necessarily, depending on where you were getting your training data, until it was too late. So they proposed analyzing your training data to make this more clear, and they came up with a technique called activation clustering. What it does is it looks at the last hidden layer of the neural net, and it tries to cluster your training data into two different clusters. One very likely to be clean, one potentially poisoned. And then you might have to look through some of the other cluster images to see if it was really poisoned or not. So we started with that technique that advance by our researchers in California about detecting these kind of attacks. And around that technique, we built a game. And in the game, we tell you that you have a number of classifiers that have been poisoned. We were the hackers, and we poisoned them. And your job is to figure out what the hidden object that we use to poison these classifiers. So they're all images of cats and dogs, but each one of these puzzles has a target object that when it appears with a cat or dog will trigger the misclassification. So in this game, you have to find it. And if you go into any one of these puzzles that we created, you see a set of two different clusters of squares. These are the training data into the two different clusters. And as part of the game, you have to explore these different clusters to see what the poisoned images might be. So you can click on the squares, and when you click on a square, it will tell you, oh, you found a clean image. And it's a little bit blurry. But when you click on an image in the other cluster, and this happens to be the poison cluster, you might find a poison image. And every time you find a poison image, the blur level goes down. So it encourages you to explore the training data and find more and more of these poisoned images. So when the first time you find a poison image, it's a very blurry photo. The next time you find a poison image, it's a little bit clearer. Next time it's a little bit clearer. I don't know if anyone can guess what the secret object. It's clearly a cat, but a cat with something else. And then if you find more, finally you see that this is an image of a cat with a guitar. So now you know what the poison object is. And so you, as part of this, you guessed that the backdoor was a guitar. So any image of a cat and a guitar will now get misclassified as a dog by the classifier. So you say that the backdoor was a guitar, and now you're asked to upload a picture of a cat with a guitar. Turns out that your favorite image search engine has lots and lots of pictures of cats with guitars. So this is just one of my favorites. So if you add this image, and we expected people to take their cell phone and try it out and pull up an image of a cat and a guitar and hold it up to the camera, and then the classifier will probably say that this was misclassified as a dog. You found the magic backdoor object. One of my personal accomplishments as a researcher was when we deployed this game, we tried it out with users, and one of the games in particular had a tennis ball as the backdoor object, and you can see this woman trying to upload many pictures of literally her cat with the tennis ball that she had lying around her house. So she didn't just go to her favorite search engine like we thought people would. And in fact, if you look closely, you can even see there's two different cats in these sets of images. So she was really trying to fool the classifier. If you want to learn more about the paper itself, you can read the paper that's going to be published at IUI 2021. But you can see that we're collecting lots of images of these cats with different objects, which are all these backdoor objects. But what I really want to talk to you about is how we built the game, right? How did we design what we're calling these AI experiences? And there's a particular process that we use to do that. For example, I mentioned before we use design thinking. In design thinking, and there's a course you can take online if you want, either from IBM, I think Stanford has one as well that's online. There's a number of different online design thinking classes. And what you do is you focus on helping users achieve their goals. You create an iterative process. They talk about treating everything as a prototype, constantly trying things out with users and iterating on them. And so that's the approach we use. In particular, if you take one of these online courses, you can even earn a badge for learning how to do design thinking. And when we built these games, in particular this Guess the Backdoor game, we actually started with 5 different ideas to get across this concept of backdoor poisoning attacks. So some you were trying to avoid the poison model, some you were focused more on fixing the poison data, some you had to focus on predicting the model classification. We would ask whether a model was poisoned, so we had a number of different ideas. From these, we developed some into wireframes or more paper prototypes, and we in particular evaluated each of these ideas on the metrics that we use as part of these games. How complex are they, right? Can we teach someone who's AI curious about this new research technique? Is the game fun? Are people going to keep playing it, right? No one wants to use educational software if it's not fun. So we had a number of these metrics in mind. And in particular, beyond design thinking now, in the intervening years, a number of companies have put out AI design guidelines that I would also encourage you to check out. So please, these are all things that can be incorporated into your user interfaces as you design them. But in particular, we also make use of open source to jumpstart the development of these games, because again, there's a pretty tight timeline of less than 4 months to build them, with a very small development team, 1, 2 developers, probably the size of teams that you might be doing in order to build a prototype for your PhD. So just to give you guys an example of some of the technologies we use for these games, we do things like Flask, Postgres databases. We use React for a front-end framework. So these are some examples. In particular, like I said, our go-to stack is Python these days, as much as I would love it to be Java. And we use things like IBM Plex for our fonts, Bootstraps for our layout, React for our UI framework, Flask for our web server, Postgres for our database. So this just gives you a little bit of a flavor. And web development is clearly a consuming part of building these games. But one of the things that I think is really important is the ability to use open source AI toolkits, because each one of these games is trying to show off some of the latest AI technology. And so we, as part of building these games, made use of different numbers of these open source AI toolkits. So some that I want to go over in particular is the Adversarial Robustness Toolbox you may not be familiar with. So here there's a link to being able to try it, and it's a comprehensive toolbox for defending your AI systems. It includes things not only like attacks, so you can generate, for example, adversarial images, but also defenses for defending your AI system against these attacks. So in particular, the activation clustering that I showed as part of the game earlier is one of the defenses that you can run on your training data, and you can see if it's possible that your AI system has an activation clustering, and you can use activation clustering to see if your model has been poisoned. There's also another technique called clever scores. This gives you a score of how robust your model would be to an adversarial attack, for adversarial, for example, images that might be used. The other game, one of the other games that I went over, is Fool the Bank. So in an adversarial attack, like I mentioned, you think about if your image classifier was trained on a certain thing like digits, MNIST. How much noise do you need to add to a given image of a given digit in order to make it misclassified? The game we designed around that was around checks. You can imagine someone might want to add a few bits of pixels or noise to a check in order to get it misclassified as an amount by a system. So one of the things we do as part of that game is we show you at the bottom of the screen here these digits, like 1, and we say which one of these is the most noisy image of a 1. This is the one that will be most able to attack your image recognition system for checks in this example, or which is the least noisy. I don't know if you guys want to play a little exercise of which one of these ones at the bottom of the screen do you think is the least noisy, has the least amount of extra little pixels added? But if you said the middle one, that is what the computational systems determine as the least noisy. But one thing we're doing is actually trying to figure out what humans perceive as the most noisy. But one thing that I think is really interesting is that we use these AI toolkits in order to generate these images. So there's another service or open source toolkit that I would point you to where it allows you to do deep learning as a service. So here in this particular toolkit, which offers TensorFlow, PyTorch as a service on Kubernetes, it allows you to parallelize the creation of dozens of classifiers and calculations of tens of thousands of images. That's what we did for this Fool the Bank game. We generated tens of thousands of images of these noisy 1s, 2s, 3s, 4s. And so it really allowed us to do these kinds of games and prepare the data ahead of time. So if you were building an AI system where you needed to do tons of this parallelization, you might use this particular toolkit. And then finally, there's other toolkits around fairness. So for example, the Detect the Bias game I talked about earlier. There we have a number of fairness checks and metrics as part of this toolkit. There are different mitigators you can use to try to mitigate the bias within your data set. And in particular, the game that is listed on the website uses some pre-processing to try to pre-process your data before the model is built to try to remove the bias. So, in summary, there are a number of different open source toolkits you could try to incorporate into your own AI systems. Things like the Adversarial Robustness Toolbox, the Fairness Toolbox, Deep Learning as a Service, as well as now there's an AI fact sheet service, so creating a transparent and enabling governance. So this keeps track of how your AI model was created, as well as an explainability toolkit. So these are all things that you can incorporate into your tool. So I just wanted to thank you guys for being able to listen to the talk. I hope you learned something about some of the technologies that you could incorporate into your systems, and I hope I taught you at least about one new AI technique, poisoning attacks, that you didn't know about before. So thank you guys.